Hello everyone, welcome to Maths with Smart Tips. Today in this video we are going to discuss the distribution function and their properties. So in the previous video of this series I already discussed the basic definition of random variable and PDF, PMF and their properties. So in this video we are discussing distribution property function and their properties. So let's start, and before starting the solution I am requesting you to all those who are new in my channel, please like the video, comment if you have any doubt in the comment section below, and don't forget to subscribe the channel. So first we take the definition of random variable. So the definition says that definition of distribution function. So let x be a random variable, then the function capital F, we generally denote the distribution function by capital X. So capital Fx, this is equal to P of capital X less equal to X, that is, this is the probability. So this is equal to, we can write P of omega such that x omega less equal to X, where the range of the X is minus infinity to infinity. It's called the distribution function of the random variable X. Now let us come to the properties of this distribution function. So first let X be a random variable and Rx be the space of random variables. So Rx be the space of all random variables and Fx be the distribution functions. Then the property number 1 says that the distribution function is monotonically non-decreasing function. That means for any xy belongs to Rx and x less than y, Fx less than Fy, or you can use less equal to y, then here also less equal to sign. And then the next property is f of minus infinity, this is equal to 0. F of minus infinity, that means limit x tending to minus infinity of fx, this is equal to 0. Now the next property number 3, these properties are very important from the exam perspective views, because based on these properties different types of question comes in different type of exams. So these properties are very important. So f of minus infinity, this is equal to 1, that means f of infinity, this is equal to limit x tends to infinity fx, this is equal to clearly 1. Now number 4 is distribution function is left discontinuous and it is right continuous. And from this property number 5 we can write here probability at any point x equal to a, this is equal to f of a minus f of a minus, since the distribution function is right continuous, but in left side this is not continuous function, this is discontinuous function. So then the property number 6, if fx be the distribution function of the random variable x and a less than b, then a probability of a less x less equal to b, this is equal to fb minus fa. Now the next one is probability of a less equal to x less equal to b, that means here the difference between a and b is in point b there is an addition point probability, which is probability at x equal to a will be added. So fb minus fa plus probability at x equal to a. Similarly in C, this BCD are related to a. How? So then C is probability of a less than x less than b. So we can write here b point fb minus fa means b point included as same as a, and then we minus the probability at x equal to b. So this is from a we can write. Now the D option is probability of a less equal to x less equal to b, that means here a point is included but b point is not included. So if we write fb minus fa, that means a less than and b less equal to, that means b point included, but here b point is not included in this equal, so we minus subtract probability at x equal to b, and since here a is included, so we can write probability of x equal to a. Now the property number 7 is discontinuity of fx are at most countable, that means number of discontinuities of the function distribution functions fx are at most countable. Now let us come to the option property number 8, and here if x is continuous random variable, then this is hold, since here we take integration. So probability of these 4 properties, from these 4 properties, this is for discrete case and this is for continuous case. In case of continuous random variable, the 4 options probabilities are same, and this is equal to fb minus fa, which is equal to integration over a to b fx dx. It is does not depend on which point included or which point not included in the inequalities or not, it is not depend upon that for case of continuous random variable. Now for probability x less than x, this is equal to fx, property number 9. Property number 10, probability at x greater equal to x, this is equal to, we can write 1 minus probability x less equal to x, which is equal to 1 minus fx. And property number 11, 0 less equal to fx less equal to 1. This is the last property. Now here an important concept, the concept is how to find the PDF of a distribution function if the distribution function is given. PDF means probability density function. In the last video I already discussed about the definition of PDF and PMF. You can check in the description, and I also share the link here in the iTab. So it says that if fx is distribution function of continuous random variable x, then the PDF, that means probability density function, is given by fx equal to ddx of fx. That means if we differentiate the distribution function, then we get the density function. And also here, if the distribution function is given, that means fx is given, and then density function is given, that means fx is given, then how we can find density function? We simply integrate fx dx with the given range, then we can get the distribution function fx in case of continuous random variable. So in this video, this is the content for this video. If the content is helpful, then please give a like to this video, share with your friends, and subscribe the channel. Thank you friends. See you again in the next video.